Good morning, good afternoon, and good evening, everyone. Thank you for joining us for the August OpenNTF webinar. Today we're going to talk about Git and GitHub with Paul Withers and Jesse Gallagher of OpenNTF. Quickly just running into the agenda. My name is Graham Akers. I'm your host today. Howard wasn't sure he was going to be here. As it turns out, he is, but he's letting me run things today, and he'll be my backup. Obviously, Paul and Jesse will be our speakers, and then we'll wrap up with questions afterwards. Just a reminder for everyone, with respect to asking questions, please use the GoToWebinar panel as shown here to put your questions in, and we'll save them all to the end of the webinar so that we can actually get the answers recorded in the video presentation that's going to be uploaded to YouTube afterwards. And I think everybody knows, but we're going to say it anyway. Yes, this webinar is being recorded and will be available on YouTube after we're done. And just a quick reminder, we want to focus on questions related to the topic that we're presenting today. Certainly, if you have other questions for the folks at OpenNTF and in the community, we have a Slack channel, and the link is at the bottom of the slide there, openntf.slack.com. It is quite active, and people do jump in and answer questions fairly quickly, so please do join us if you haven't had the chance to get in there yet. Also want to say a quick thank you to the sponsors of OpenNTF. HCL has been a supporter since the very beginning of them taking over the product suite from IBM, and we're very thankful for their contribution. And for a very, very long time, Prominic has played a role in hosting all of our IT-related services, and we're also thankful to them for their contribution. Another reminder that this is a whole bunch of volunteers that are all geeky and thrilled about Notes and Domino and Connections and all the other products, same time and whatnot, that are part of the product suite. And this is the place to come to share and ask questions and learn things and contribute if you end up developing something that you think is kind of cool. Even if you don't think it's kind of cool, if it's handy and useful, please do share it. We all learn from each other, and would love to have your contributions. Quick note about September's webinar. On the 23rd of September, we're going to do a presentation on the Domino online meeting integration. This is new and released just recently. Paul, Devin, and Rocky, all from HCL, are going to come and explain how it works and give us a demo. So that sign-up link isn't working just yet. Howard is going to have that up and running in the next couple of days. So just bear with us, but you will be able to sign up in the normal way. And also just a quick note about other things that are happening in the community before we get started here. DNUG has a lot of things that are going on a regular basis. Jump into their website at dnug.de. The vast majority of their stuff is broadcast in German, but they do English language broadcasts on various odd topics. The next one coming up is on Domino best practices. Of course, we have collabs here coming up in October, and registration is open for that now. I have registered, and also accepting abstracts until the end of the month. So if you'd like to speak, please go ahead and submit an abstract. And if you've never spoken before but have thought about a topic that you're interested in presenting and aren't sure about presenting, lots of people in the OpenNTF community and the community at large would be happy to help out and either pair up with you or offer feedback. I've certainly coached people on doing presentations in the past, so by all means reach out to me or anybody else associated with OpenNTF. We'd love to help you and very much support new contributors in the community. I know Richard has said often that he holds spots at Collabster for new speakers, so please do sign up if you want to speak. And finally, Engage in March in Belgium is also slated to be an in-person event. I've been to Engage twice, and it's a pretty amazing experience, a really wonderful conference. Theo does a great job. So if you're interested in checking that out, there's the link to be able to register as well. Okay, I am gonna stop showing my screen and switch over to Jesse, and we will get going here. Where are you, Jesse? There you are. Okay, you should be good to go.
All right. So Hello again, everyone. So I will be handling the first part of this. I'm going to talk a bit about what Git is, how it's generally used, uh, and then some of the specifics about how you would work with an NSF. There are some quirks that go along with that, and then also a little bit leading into about what GitHub as a service adds on top of Git. So there's it's very natural to kind of conflate the two, but there is a bit of a distinction. And then after that point, I will hand it off to Paul to go into some further information. Uh, as a little bit of a disclaimer before I get into everything here, this is a deep well. There is a lot to know about Git. I cover some of the topics. There are huge categories of things that some that I do not cover. Some of them I know and didn't cover. Some of them I don't know and didn't cover. But I'm going to talk kind of generally about like here's the basics of it, and then provide resources. So some of the hope here is that I will provide you with the baseline to then learn more as you need to. Just because a full tutorial on Git is a much larger topic, but fortunately that is well covered. Really, here I just want to help sort of demystify it if you're not too familiar with it, kind of get the basics of like what this is, and hopefully a little bit of like why you might use it and how it will interact with Domino. So what is Git? It's a source control system similar to SVN, Subversion, et al. So you may have used some of these in past environments. You may use different ones in current environments. Like there are still active source control systems that use ancient ones or other competing modern ones. So it's kind of like the general source control, which I should have actually defined here, where source control means rather than just saying you have a pile of source files or an NSF and you make changes to that, and then the current state of the app is the current state of the app. What source control lets you do is say, I have this starting point, I make this change, I make this other change. And then having that means that after you make a change, you can revert back to a previous one, or you can branch off in a different direction. And so this is something where you suddenly, like, you essentially have interactive backups for your code as you're working. And that's the baseline where essentially you have this system of doing this. So whether that's just for individually, and then it also lets you work with others. So this is as opposed to the I'll say the standard notes system of, well, there's an NSF on the server and sometimes I will make a copy of it. That is not a good system, and so this is you'd use source control for that, and certainly source control is not unique to NSFs. It's harder in NSFs than usual, but it's a general system. And Git is the current probably dominant. I mean, I guess I don't technically have figures on like how many lines of code are in different systems, but certainly by mind share. And if you're looking for any kind of source control tutorial, unless you explicitly look for something other than Git, you're going to get Git, and it's good. Git itself is an open source project and a tool. There are many different servers and hosting services such as GitHub and Bitbucket. So again, it would be very easy, especially if you're not familiar with this stuff, to assume, oh, GitHub is Git. Well, no, GitHub is the site that uses Git. It uses it extraordinarily well. But it is good to know that like that's not the only one, and Git is not a project of GitHub. Git's its own thing. It's its own system. You don't even need to use a service or a server at all to use Git if you were so inclined. So the Git conceptual layout. This is admittedly a tough thing to visualize. I've looked around and I see a bunch of different um, diagrams for this sort of thing. Everyone's a little different and they're all good in some way. But essentially, Git is a series of commits, one or more file changes relative to the previous state. So you start out and you have an empty repository, and then you add a file like hello.txt that just says hello world in it, and then you commit that. Now you went from empty to one file with hello in it. Okay, next commit, say we're saying commit B, you now add hello2.txt. Now you've added this two files. So now you have this sequence of events that are additive onto each other. But you can branch off from one of these commits and say, starting from this point, I want to go off in a different direction and add, some hello3.txt or what have you, and then later merge back in. So you have all of these additive commits, and they can be off in different directions. So, this branch over here has parts of this branch. This does get complicated potentially, but the idea is that you still just have all of these deltas between states, and like that's the core of it. It's presented programmatically as diffs, like text file diffs, if you're familiar with those. It's probably implemented in that way largely too. And so it's really these changes between states that are important. Generally, you'll have one main branch. So, in newer repositories, it tends to be called main. Historically, it's called master. No need to go into why, but those are essentially, by convention, the primary branch. So in practice, that might refer to production versus something that's in testing or in development. You don't need more than one branch. You can do everything in the main branch, which is often the way it works when you're just starting out. But technically, those don't have special powers. Like a server might treat them specially, you might treat them specially, but they're just a named entity that are equal to anything else. So if you have one branch that's called main and one that's called delete me, they're equivalent functionally. You just might know that main is the actual production stuff, and maybe delete me is not the one you want to deploy. So commit itself, like I was saying, is an individual unit of changes in repository. So I'd say unit of changes because it can be any number of things. So it might be a new file added, it might be a file deleted, it might be a file changed, it might be like adding a new submodule. There's any number of things. Right? I guess it's mostly those, but it's any number of things that you might add into these. So it's at least one change is packaged up into a commit. In practice, I'm showing a screenshot from a GUI here. You can use the command line. I'll talk a little bit more about the GUI options later. Generally, what you'll do is you'll say, I want to select these files that have changed. You'll give it a message. There are styles related to these. So this is kind of like up to you, your personal preference or your team. The most common are things like does X. So the idea is that you're saying that this commit does something. Or some people will use more of a past tense, where it's more like I did something. And so, those are essentially equivalent. The main thing is that you don't want to just do made some changes or X or something. There are a lot of perfunctory things that you might put in there just because it's a required field. You want to make sure, even if you're the only one who's ever going to see it, you want to make sure that this is here, that it's useful. Because, for example, you can revert a commit later. And so if you realized, oh crap, I made a mistake 3 weeks ago, you can look for that commit by message and say, that's the one, I want to undo that, revert that. That's not so good if it's just 300 unrelated changes and the commit is made changes. So you also want to, I didn't mention this here, but you want to make these kind of like distinct units. So for example, if you add a new form and an associated view, you might do those two things as an individual commit, saying, add person entity, where it's the form and the view that has to do with it. And then if you add a different conceptual noun to your database, you would do a different commit for that, even if potentially, even if you did them at the same time. So, sometimes you'll just do all of your changes all at once. Sometimes you'll break them up. It kind of depends on how they're related. You want to keep related changes together and not bundle a bunch of unrelated changes unless you are in kind of an exceptional situation. If you're using an issue tracking system, do include an issue number. And a lot of them, GitHub in particular, will automatically link up commits that you make to issue numbers. So if you say, fix bug where, X, Y, or Z happens, and then in parentheses, you say issue number 310. If you go to issue 310 on the web, you will then see this is referenced by this commit. And if you go to the commit, you will say this is referencing this issue. So having that sort of thing can tie it all together. There isn't an individual field for issue, but generally services like GitHub will pick up on kind of the standard textual ways to write that. So that is extremely handy to have that kind of history in there and that linkage together. It makes your project on the site all the better. So beyond commits, I want to talk about a couple concepts and put them in sort of a notes-based light, because that's usually it's a pretty good reference point for all of us. So there's the concept of a remote. Git itself, in a lot of ways, you can think of it like replicas of an NSF. So There are different ways that other systems do this. So in other systems, you might specifically check out from a server, and the server is the real repository, and you just have a special local workspace kind of thing. With Git, essentially all versions of it are equal. Your version on your desktop and the version on the server are equal. And so you rationalize them. You can do, effectively partial replication where you don't bring down all of it, but you are essentially bringing down and synchronizing the entire repository. You can have multiple remotes. So for example, you might have, if you're working on a proprietary project, you might have one that's, internal only, but then you open source it. So you add GitHub as a remote, or you might have, a private and a public repository, or if you're migrating from one to another, you might have multiple ones, but almost all the time, you're only going to have one remote, and it's probably going to be called origin. So much like main, that is largely convention. It's possible that some of the Git commands will have like origin built in as a default, but essentially origin is the conventional name just because that's the nice name that everybody settled on. The next topic would be tags. So this is something essentially like bookmarking an individual commit. So if you have, at some point you'll say, I'm done, this is version 1, or this is version 1.1. You might tag that commit as saying, this is the release that went with 1.1. So that's useful in the repository itself, where you can then say, I want to browse the tags and go to this commit. So for example, if you're trying to reproduce a bug that only happens with a specific version, you can go to that tag and then build from there and say, I see that. And additionally, again, with GitHub, GitHub will see tags and can treat them as versions, and then we'll make a little mini page for them saying, these are the changes that were in this one. You can attach files saying, this is the binary release for this. And so it becomes part of this overall system of releases and distribution. So tags are very handy for that. You can use them for other things, saying like, this is before I did some terrible thing, but most commonly I use them for release versions. And then finally, the one that's a little less common to run into, but common enough to mention, is submodules. So essentially, a repository can have a reference to another repository. This can be very handy, especially if they're related projects, but the other project kind of runs on its own, or if for storage reasons you might have put a whole bunch of binary files in one submodule and put it there. It's very easy to go a little crazy with these, because while they work, they do get fiddly and annoying, and it's easy to kind of run into weird problems. So only do this when you know what you're doing and you have a reason, but it is highly possible that you'll run into it, because you might run into issues with making sure authentication is the same between them and all that sort of thing, and it can get a little annoying. They do work, they do show up, but it's good to be a little wary of them. I'll mention a couple extensions. Extension is a loose word for this. The first one I mention is one that is I found extremely handy to know about, even if you don't follow it to the letter. But this is Git Flow. So by default with Git, you just have the main branch and you can add commits, and that's it. And there's nothing about Git that will tell you how to work from there. Like, you have all of your options, but something like Git Flow is an idiom saying, okay, how are we going to handle production versus development, or release candidates, or hotfixes, or individual feature additions? Git Flow is a codification of those, and then there are extra tools. So a lot of GUIs will have this built in. There's a Git Flow command line tool that will handle this for you. And so rather than saying, I want to create a new branch called, adding person documents, you would say, I'm starting a new feature, add person documents, and then you will finish that feature. Or you go in and say, I want to start a new hotfix off of the main branch. All that becomes built in. There's nothing that Git Flow does that you can't just do yourself. But it's very, very handy to have this or something similar to it as a system for how you work with the repository, either, again, individually or with a team, which incidentally is kind of a theme for a lot of this Git stuff, where there's a lot of things where you hear source control and you hear GitHub and things, and it's all about team and collaboration and working with others. In Designer, as you'll see, it's called team development, but all of this is just as important really for individuals. Like, I have tons and tons of projects, even if hosted locally or not, or publicly or not, that I'm the only person who ever does anything in them, and I use all of these systems. well, not so much pull requests, but I use all the other systems just because it's essentially like working with a net as opposed to working without one. Like I feel very uncomfortable when I'm doing development not in source control. So all of this, including Git Flow, handling branching and features and develop versus production, I do all of that, even when it's something I only write and I'm the only one who ever uses it. It's absolutely worth it. Then the other one, which actually is more of an extension, is Git Lfs, which stands for large file storage. So Git in general is geared towards dealing with text file differences. So, a Java file or an XML file or what have you. It's very, very geared towards dealing with those efficiently. Dealing with the differences between a 3.1 megabyte and 3.2 megabyte JPEG file is not efficiently handled. What they did was they added this general system that pretty much every hosting service supports at this point called Git Lfs. And this is a way where you can say, okay, take anything that ends in JPEG or zip or jar or what have you, and put that in large file storage. You can think of it kind of like Deos, where it's handled specially for you as the developer. You don't have to think about it once it's set up, but the system, Git, and the server can handle these things more efficiently without bloating up your repository. I've had a couple cases where I put binary files and had differences without using Git Lfs, and you will blast through your repository storage limit extremely quickly doing that. And everything will be very slow and annoying in your GUI. That's something that every time you clone the repository locally, you do have to initialize it, but a lot of GUIs at this point will notice what's going on and handle that for you. Either it'll have an option to just say initialize, or it'll just do it. And finally, I have a couple links to resources here. So this is where I was saying, this presentation is meant to kind of whet your appetite, and then you can find more detailed tutorials. You can go down, you can spend hundreds of hours watching YouTube tutorials, reading these, and I recommend that you don't necessarily need to spend hundreds of hours, but I do recommend that you visit some of these, read through some of them, look for tutorials online, and familiarize yourself with it. It will absolutely pay off. I want to talk a little bit about some tools that you can use on top of Git. So Git itself is pretty much fully command line. It was designed first for the command line. There are people much like all the people who use VI for their work, people will use Git on the command line as their interface for working with repositories. It works, like that's all of the code is there, but it's very daunting for when you're trying to get into it. And even if you are familiar with it, like I very rarely use the command line version of Git, and I use Git all the time. So usually you're going to want a GUI of one kind or another. These will, they'll usually just wrap around the Git command line itself. And so what will happen is you'll see kind of command line output when you do something, but they'll expose options that are there from the command line in a much more intuitive ways, like seeing what's available, seeing what the options are. And then they also provide nice visual ways to see the history of it. So, the Git command line will have options for saying, show me commit since whatever, but it's much, much nicer a lot of the time seeing it in a table in a GUI with lines going between them, seeing what's going on. And then a lot of them will also support extended features. So I mentioned how they will handle LFS for you, but they'll also do things like, for example, you might be able to manage GitHub pull requests, which are not a Gitism, they're a Githubism. But some clients will just have options now where you'll have your commits, you'll have your branches, and you'll have your pull requests all in line, and it's very handy. So there's a bunch of them, free and non-free. Kind of one of the go-tos for a long time has been Sourcetree from Atlassian. I know it's kind of like gone in waves as to how actively developed it is, but it's been, as far as I know, solid for a good long time, and it has been free for Windows and Mac. From a number of years ago, there was a Notes and 9 episode specifically talking about using Sourcetree as in the context of Domino, so I definitely recommend that you check that out. There's also GitHub Desktop from GitHub, so that one's focused on GitHub specifically. I don't think it has support for other Git hosts, but it does mean that it handles essentially all of GitHub stuff nicely and integrated in a handy way, so that's a good option. I personally use an app called Tower, which is a for-pay Git client. I quite like it. I find it very stable and speedy. So if you're in the market, maybe give it a shot. The other ones will absolutely do just fine. I personally quite like this one. And then the Git project has a list of GUIs for various platforms. So beyond these, they cover a whole bunch of ones that are available for Linux and Windows and Mac OS, and different ways of doing Git and different extensions. And it's actually a very vibrant community. There are new tools on a fairly regular basis and major updates to existing ones. This is kind of what it looks like. I realize looking at the time, I'll speed through some of this stuff. So here's what I'm talking about, where you have a series of commits and you can see the lines seeing like, here's how these commits got into the current state that they are and where they ended up in the branches. So this is much, much easier to read than the command line. I want to make a quick mention of SSH. So Git can work over a bunch of different protocols. The main ones are HTTPS and SSH. So if you go to GitHub and you want to clone, it will give you those two options. Many hosts allow or require it. And then this can be fiddly in all cases if you're not super familiar with SSH, and it's especially fiddly on Windows, in which case, sorry, you're using Windows. Usually though, the general gist of it is that you create an SSH key pair, so public and private, locally, and then you give the public key to your host, and then you use that to connect. There's a tutorial for doing that with GitHub specifically linked here. And then usually other ones like Bitbucket will have similar tutorials. So I want to talk a little bit about working with an NSF. So, up until now, it's all been Git in a general sense. And now here's touching onto the mechanics of how Designer and an NSF interact with this. So Designer can sync between an NSF and an on-disk project. So from here on out, and in general, I use the term ODP for short. This project is a folder on your file system that contains all of the design elements, almost all of the design elements exported as DXL. And then some of them, so things like X pages, you'll have the XML for the X page and then an extra DXL file, similarly with image resources and file resources. And it's actually a pretty good way to represent a project in general. Designer uses the term team development to refer to this NSF ODP sync. So that's good to know. So in the preferences, you'll see team development. What that means is essentially source control enablement. It's a fine enough name, but it's just good to know that that's what that means. One note is that it is implemented as an Eclipse builder, which means that to do this sync, you should either have build automatically turned on, knowing all the consequences of that, or explicitly build your app to sync. I believe it's still the case that it's done this way, and it certainly was the case in the past. A couple quick tips about this. Most likely, you'll want to turn on binary DXL in the Designer preferences. This applies to all databases that you're working with. This DXL format is not that nice. It is still DXL, it is still XML, but for things like the form body or a number of other specialized components, it will just output a big base64 blob essentially. And so if you add a field to a form, the diff that you're going to see in Git is just going to be that part of this base64 thing changed a little bit, and you're not going to see, oh, adding this field thing. So that kind of stinks, but it's useful because DXL still is not fully safe to do round trips. There's still a couple known things where if you do this in an NSF and you export it in the non-binary format, it will be lost. And so unfortunately, it's safer to do this even with the downsides. It does make collaboration more difficult. It makes, it makes just seeing the changes more difficult, but it's an unfortunate necessity. And then another one, I recommend putting the ODP in the subfolder of the repository. So your first instinct might be to say, I've created a Git repository. I want to browse and put the location of this as the Git repository. That will create pain. That will cause Designer to import Git metadata into your NSF, which you do not want. And then it will also make it more difficult to add other NSFs and other build components to your repository. So at the very least, you want to have one subfolder. And then I also recommend putting a second subfolder of that called ODP, which will come into this a little bit later. At the very least, you want one subfolder. You may want to go further than that. So like have NSF / some NSF / ODP. At the very least, absolutely not in the root, definitely in at least one, maybe in two. You'll also want to get Swiper. So this is a project from Cameron Gregor on OpenNTF. And while it's not explicitly mandatory, it may as well be. So the DXL exported by Designer by default contains a bunch of extra metadata that is not useful to have in a source control repository, such as some signer information, some last modified, things like that, which is not important because the last modified is the commit time, not when the note on disk was last modified. That is not useful. Swiper will handle taking care of that. It will also nicely format the XML in a way that's a little better than the standard format. So I'd say get this and install it and just have it enabled for everything. I want to do because I have to, quick mention of the NSF ODP tooling. So this is one of my pet projects, handles building on this project. It's not directly related to Git, but usually once you end up down this path, at some point you're going to want to do automated builds, and this will help. I have a whole presentation from CollabSphere last year. I've mentioned it in other situations, so I'll leave it at that, but this is good to know. As far as some tutorials for using Designer, there is official documentation. I don't know that it's been updated since 901, but it's still the same. And then there is this whole series of notes in 9. Before I upload this, I will get rid of those timestamps in there, in those links. But there's a whole series of notes in 9 videos that are, still accurate. Some of them I believe talk about using Git in Designer, and some of them I believe talk about using Mercurial. Neither of those are exactly what you'd want to do now, but in general, the concepts are still there. And then I wanted to talk very quickly about some Githubisms. So I mentioned things that are specific to Git so far, but there are some things that GitHub adds on top of it. One of those is the ability to fork repositories on GitHub's side. So it allows you to create a full copy of a repository in your profile organization. So you see an open source project and you want to say, I want to make my own version of this, or I would just want to poke around with it and tinker with it, or I want to start collaborating. You can fork the repository, which will essentially make a copy locally that will then diverge from there. It does maintain a loose relationship back, which is handy because that lets you do things, and GitHub recently improved this even, where you can say, I forked this 3 months ago, they've made changes, I want to bring in all those changes, and GitHub makes it easier now. You can use this either to say, I just want to outright fork it in like the software project sense and say, leave the old one behind, I got my own now. Or you can use it to have your own little workspace and then send things upstream. This allows you to not have permission to make changes to the main repository, but still have to make changes locally and then ask them to add that in, which I'll get into next. Technically, they're two distinct Git repositories protocol-wise, like they don't have a relationship as far as Git is concerned, but GitHub does maintain that relationship. And then finally, I want to talk quickly about pull requests. And so this is something that you say, I've made these changes and I would like the maintainer of this repository to add this either to another branch in this repository or to another repository that I forked from. So depending on your organization, so if you're just working on an open source project, you'll probably fork it and then make a pull request from your fork. If you're working in like a corporate environment, but somebody like there's a maintainer of the develop branch, you'll work in your own branch and then make a pull request from your branch to develop. And so that will all be in the same repository. So you're allowed to work in the repository, but you're not allowed to update main or develop directly. This includes all commits in your branch that are not present in the destination branch. So this is kind of like grouping together commits. So this is something where if you're working on a large feature, you might do, 6, 12, any number of commits until you're done. And then when you are finished, then you make a pull request saying, take this giant pile of commits. This represents some larger conceptual thing. Please add this to develop. There are whole workflows on top of this where, you can have checks that run automatically. You can have systems where you need approvers and all sorts of things. So this is a mechanism for getting in there. You don't need a particularly large team to work with this. There are cases where, for example, you just use this as a kind of self-check, and then you merge your own commits, your own pull requests in. But it is especially nice if you have a lot more lockdown organization, and this can be actually enforced as part of the flow. This does also pair well with Git Flow, where you say you have a feature branch that says, I built this feature, it took me a while, but I'm done now. I want to merge it and develop. You'll have some checks that say, is this safe to merge in? Does the build pass, etc. And so it can be good to have that kind of larger conceptual unit. And so I think there I will hand this off to Paul, since this leads nicely into talking more about GitHub workflows and things like that specifically. I will stop showing my screen.
Let me share my screen.
You should be good, Paul. Excellent.
Okay, so hopefully you can see my screen now.
Yep.
Yep. So I'm going to cover more on GitHub itself. GitHub has become the de facto place for Git. There is GitLab and Bitbucket, but GitHub has become a very heavily used site, so heavily indeed that Microsoft bought it, I think a couple of years ago, and there are a lot of new features constantly being added to GitHub, and I'll cover some of those newer features as we go through this. It's not just about your code. A good repository will have a number of other files along with it. And as the person who set up the open source project office at HCL, and I do a review of third-party open source projects that we're wanting to contribute to. The repository files are one of the areas that I look at on those. So there's a number of areas here, from the README through to the license file, notice file, contributing code of conduct, an authors file, and the issue templates and pull request templates. It may seem like a lot, but actually adding this information, adding this content will make your life easier as the maintainer of the project. So the README, this is your selling place for the project. This is the content that people will first see when they look at the project. There are some open source projects out there where the README is just a couple of lines long. It doesn't present a very good impression of the effort that has been put into the project. There may have been a lot of effort put into the code. It may be very good code, but it doesn't present a good impression of the thought for other users. So let's look at some of the things that you should be adding into these. And I'll go across to some repositories to work through these. So first off, badges. Badges are things that you can add to repositories to reference other integrations that it uses. This is on Domino online meeting integration, and we're using Vertex for the web app, and so we've got a badge there. Let me just refresh this, and hopefully I can. We can edit it. Let me just go to my preferences actually and switch back to. Where do I switch to theme? Settings. Yeah. Graham, is the black too much of a problem?
The white was better, but I think we can see what's going on.
Yeah.
Okay. There's some feedback saying that it is hard to read.
Let me try and remember appearance. That's where it's going to be. Default, mate.
There we go. Good.
Yeah. So long since I changed that, I forgot where it was. Okay, that sorted that out. So when I look at that README, then we see that this is just Markdown. So we've got the link there and the URL of the image. And so when we see that, then it shows that badge. there. There are a lot of badges that are available. This one is, this Node-RED here is using Travis for its automated build. So we can see the status of the last build, for example. We can also see it's also using coveralls for code coverage in tests. So we can see what the coverage is at the time. So again, this is kind of improving the look and feel, improving the feeling for users for the project. Vertex itself, we can see that the continuous integration there is working, and this has been using GitHub Actions. So that's one of those things that it can display. The big thing that you want to cover off on the README is the purpose of the project. So this is another one of HCL's GitHub repositories, connections automation. And so it's giving a lot of detail on what the project is for, pointing people to frequently asked questions to deal with, to cover off quick problems. And again, that kind of thing, it can be here, it can be in an issues template, which I'll come back to later. But this is then trying to catch any problems being raised that have already been highlighted. So, so trying to minimize the amount of times that you as an owner of the repo get pinged about it. Similarly, requirements. If there are particular requirements or prerequisites for the project, pointing them out on the README then tells people up front what those are and stops them wasting their time if they're trying it with an operating system or a set of prerequisites that are not intended, and stops them raising issues for those as well. And also kind of how to get it working. So this is going through a lot of steps for that. But all of the setting up for it. If this is going to be more extensive, then it may make a bit more sense to put this into a GitHub Pages site. But if it's not too extensive, then the README kind of covers that. And then also acknowledgements, the reference to the license, and a disclaimer, always useful stuff there. Again, supports. So we had some problems with, we had some contact from HCL supports early on with Domino where they were getting queries rather than issues being raised on the GitHub. So we explicitly put a statement here to raise issues through GitHub. Links off, if you've got a GitHub Pages site, then you can link off to that there. And similarly, it doesn't just have to be a README at the top level. Here's the app dev pack samples repo, and there are READMEs in each of the sub projects for it. So it doesn't just need to be at that top level. The next, the next area that we need to cover off is the license. Now, the preferred license from OpenNTF is Apache 2.0. It gives the greatest flexibility. There are differing types of licenses. There are copyleft and copyright. Copyleft require any project from it to be circulated as open source, which limits how it can be used in a product. It also can become a problem for other open source projects as well. Copyright, those are Apache 2.0, MIT, and BSD 3 clause are the three main ones there. Those are much more permissive. It makes it much easier to use those. Licensing is a bit of a minefield. There is a nice website called choosealicense.com, which gives a lot of details about those and compares them. The license that you use will, in many cases, depend upon what third-party resources you've got. If you're using a third-party resource that is GPL licensed, for example, you can't use that. You can't make your project Apache licensed. The copyleft licenses require any project that they're part of to have the same license. Whereas something like MIT, you can put that in an Apache 2 license project without any problems. Most of them will give you some standard text to put into your project. If we come across to Domino, for example, we've got the license file here that you put at the top level, and the key bit is to remember to change the copyright information at the bottom. If you put that license file in there correctly, then GitHub will automatically identify which license it is, which is very useful. And then there are certain files, if you can put reference information in the top, then there's the desire to add those. Just trying to find one. Yeah, so here it is in the script library. It's a much briefer piece of information, but we've also got that copyright details there. So if files don't allow that, so a form, for example, wouldn't allow you to add that short boilerplate, then you don't need to include that. But if it can, then it's best to include it in, particularly around script libraries and agents, because if that script library is copied from one NSF to another, it's still got the license information and copyright information in there. So it avoids any confusion with that code being used out of context. The notice file is another important one. We've got that here. So in the notice file, you'll reference any third-party code that you're including in. So this is using OpenLog. Here's one. Domi has quite a bit more in it. And so we're listing out what the third-party project is, what its licensing is, a link off to it, and what the copyright is for it. Contributing file. This is one that might not get added very often, but it's important to add it again to minimize what you need to do and queries coming to you. If you're not accepting contributions, then it's helpful to explicitly state that. That might be a case if it's just a demo and you're just throwing it out there. There may be other projects where for whatever reasons you're not accepting contributions. You can also then cover process. So do you want people to raise an issue before a pull request? Do you want to push them through opening a discussion before making any changes to identify whether or not that is a change that you want, discuss other impacts around it, and that way you're saving the person who's working on it time, and you're saving yourself time as well. If there's specific setup that's required around the development environment, Jesse mentioned earlier that in Domino Designer you can turn on or off binary DXL export. For Domi, for example, we have binary DXL turned off. It's quite a limited set of design elements there, and we're comfortable that the DXL round tripping works fine for those. So that's the kind of thing that you would want to specify there. If it's Java project, the Java version that people need to have might be worth covering there in case they don't already have that installed. Style guidelines. The last thing that you want with a pull request is to have loads of files changed or loads of lines within a file changed because someone's got a different line length setting. So if there are specific settings that are required, style guidelines also for the documentation, for example. Sometimes you can actually have those settings and preferences exported from your IDE as XML files, added into the repo, and point people towards those to import in. And also, do you want them to test locally before pushing up? If you have a CLA process, all of the GitHub repositories on OpenNTF, for example, has a CLA process. Similarly, all of the HCL ones have a GitHub a CLA process. Referencing that upfront on the contributing file manages those expectations in advance. The authors file, that's a much more down to personal preference, really. But what it can do is just give a single point of reference for everyone who's been involved in the project at any time. There's no real specific requirement around that, but it can be nice just to highlight all those people. If you're using that, then obviously the PR template, you want to get people to remind people to actually complete that. And the changelog can be used for a list of changes for each release, for example. So on to issue templates and pull requests. So these are extremely useful for managing the processes around issues and pull requests. And I just want to cover how they're used. There's some good documentation from GitHub about using issue templates and pull request templates. They're just Markdown files. And that makes them very easy to set up. You can set up issue templates directly within the IDE of GitHub itself. So if I can here go across to settings and under issues here, under features in the main area of the settings, you can set up those issue templates and you can set up multiple issue templates. So we've got one for bug reports and one for feature requests, and it's just a Markdown file. So you can specify labels for them, specify a particular assigner for them, add in default text for the issues, and add in the steps here as well. So here specifically under feature requests, there was no intention ever to support repeating meetings here. So I'm explicitly calling that out at this point. So if someone creates a feature request and intends to put that they want repeating meetings in there, it's showing them straight away. That's not going to be supported. Don't bother even submitting a feature request for that. So again, saving both sides time. The pull request templates. So when those issues templates are actually saved, they're put into a GitHub issue template folder. So we've got the IDE to kind of manage them, but this is where they're actually stored in the repo. You can create them manually outside of GitHub, as long as they're in that .github folder and your issue templates are in an issue_template folder, they'll work fine. They don't need to be set up on GitHub itself. You can, I haven't really used this functionality, but you can also, there is also the functionality to set up processing to auto close issues by using a YAML file. I'm sure this is well documented on the web, but so here issues will be closed after 14 days. It will have the needs more info label on them, and this comment will be put onto the issue. So again, it's making things easier for you as a maintainer of the project. Pull request templates. This is the one for Node-RED. So again, it's just Markdown. This is directly in the GitHub folder, because there is only one pull request template, but there may be more than one issue template. The issue templates are in a subfolder. The pull request, because there is always only one, is just at this top level. And if I switch across to Visual Studio Code, here's one that I've got there. Those checkboxes that are there, that's just square brackets with a space in between. Square brackets with an X is then a checked checkbox. So that's very straightforward. And if you set those up, then the pull request template will be seen when people create a pull request. One of the things here, due diligence, I'm telling people what I want them to do is to have tested locally, checked the next and previous page, and updated the data. So you can add things in there to remind people to do steps that they might forget. I actually have a repo internally where in the pull request, I've explicitly stated to update the version number, and every single time I create a pull request, I then have to go back and do another commit to change the version number because I've forgotten. Thankfully, because it's on the pull request template, it reminds me. So yeah, in short, there's a license file there. You can also use the cog next to a repo to add information about it. So here on Domi, for example, cog here, so you can add a description, you can add website links for it, you can add topics, you can specify what other things get included in the front page. GitHub automatically detects what the primary language is. Here, the primary language is Java, but that it's adding that information just adds some extra highlighting around the repository. Some other functionality, GitHub Pages, discussions, projects. Oh, I've got GitHub Pages on there twice, and actions. So discussions is something that was added quite recently. So let me find, which one was it? Connections. Connections automation is a very good example of where discussions have been used. They've got lots of discussions there. That's again enabled in the settings here. Discussions. That's a new one that's there. Projects gives you project boards. If you're working heavily on a repository and you've got a lot of issues, that gives you a Kanban style board that you can drag issues around to track what you're working on at a particular point in time. And table of contents is another thing that's quite new. GitHub will automatically generate a table of contents then for any Markdown files. Github Actions allows you to manage some kind of automation. I've not really used them very much, so I'm not going to talk about those. But they can trigger actions to take place when a pull request is done or when a submission is done to a particular branch. So GitHub Pages. GitHub Pages is a very useful thing for doing documentation. And it's so useful now that GitHub have moved it out into its own separate page. So GitHub Pages, you choose which branch to pull it from. You can pull it from a particular folder as well, or from the root. And that then gives you a website, basically, that you manage using Markdown files. So that's actually what I'm using for my blog. It's what I used for a Nomad tutorial a couple of years ago. It's also what's being used by the Domino REST API, aka Project Keep, for the documentation there. And that's using a specific theme called Jekyll. So there's great documentation about GitHub Pages, and because it's built upon Jekyll, that can actually be run locally. It auto builds on there, and there's a lot of flexibility and functionality that's available with it. Jekyll is there's a website for Jekyll that then walks you through setting it all up. Is it on this one? Oh no, I know where it is. Oh yes. So there are some prerequisites that you need installing Ruby and Bundler in the docs on the quick start. Yeah, talks you through the steps to set it up, and then you can run that site locally and see how it looks before you then push it up. So that's what we're using here. Let me just let's get to light. That's better. So that's what we're using for the Keep tutorials site. So it consists of some templates, which are up here in the layouts. So these are the layouts that your pages will display, and it's mainly just HTML. You can then include other pages, so it's including the heads there, which is a portion of HTML. Think of it kind of like a custom control or a subform that you can then include in. And what it also has, Jekyll will also allow you to use something called Liquid. Now, Liquid is a syntax for programmatically including content. So back here, for example, if I go to the footer, then if site.author, so if in the config.xml there's an author defined, then display the author in there. And if there's an email, add a link to the email. It's very well documented on the Liquid site about how to do that. And it can then get extremely powerful. That's what we're using for opensource.hdltechsw.com. It looks very powerful. We've added some additional functionality in there for things like filters, but and thankfully Tony Blake's team made this look a lot nicer than I did originally. But this is just a GitHub Pages site. It's just using Markdown and Liquid for creating these tiles. Similarly here, you can also use point to data. So on the landing page, that's the one. Site.data will map to an underscore data folder. So it's going to the tutorials JSON file there, which is just an array of JSON objects. And then for each of those tutorials, obviously because I've used the variable tuts there, then the reference to each of them is a king tut. And then it's just referencing the values. And Liquid allows you to do things like joining arrays. Here it's the out-of-the-box option there for joining them is a comma, and so you can just create those pages. Creating an individual page, then you tell it which layout to use. You can add data on there, which you can then reference in the layout as well. And then it's just HTML for main, Markdown for the main content. And then you can display that site with bundle exec Jekyll serve. It builds it all locally and runs it by default on port 4000. You can change that port by adding --ports 4000, I think, or 4001 or whatever. And we've got those. If I go back and go to this tutorials JSON file, add another one, save it, it's generating the feed, building it, and it's done. And we've now got 3 there. So it's very easy to set up some very powerful documentation there. And a lot of sites, for example, Node-RED's documentation is all GitHub pages, and you can specify custom URLs for it as well. Dependabot and security. Dependabot will kind of prompt for security. You can also set it up to automatically generate a PR if it can, to solve the problem, which is very useful. And there's more information there about GitHub Pages. Gpg Signatures is something that you can set up. It's a bit of an involved step, but what it gives you is on the commits, then you get this nice green verified badge on each of your commits, proving that this wasn't spoofed by someone else. It was actually pushed up by you specifically. And that's everything from me. So, Graham, back to you.
Excellent. Thank you, guys. I will just switch over to me. And we're going to show, click OK there. How come I can't click OK there? There we go. All right. We'll transition over to questions. Again, a reminder for folks using the questions panel to type in your question, and we'll have a quick chat. We've just got a couple of questions here. Good questions, though. So we'll start with the first one. Greg asks, what software on Windows can be used to read and write .md files or Markdown files?
So I actually downloaded a piece of software called Markdown Pad. It's not as great now. There was a problem with the display of it. So it doesn't display, the fonts are really blown up now. So the one that I use is Visual Studio Code.
Maybe I'll ask for a definition of what is a Markdown file.
So a Markdown file is a file with an extension .md, and it allows you to add some basic formatting with just semantic information for it. So a single pound sign will make an H1 title, 2 pound signs H2 title, dash will make a bullet point. If you if you number them, then it will turn them into numbered bullets. You can add in images nice and easily there. So it allows you to do a degree of formatting without needing a rich text editor. And if you saw my session at Collabsphere last year, then you know what a train wreck rich text editing on the web is at the moment.
I would add a Markdown file is a text file, like an HTML file is a text file. So it's got some predefined formatting, and there'll be any number of YouTube tutorials that can explain how that formatting works. But as you could have seen during Paul's presentation there, he was editing Markdown files in a browser. So you can edit it in a text editor, you can edit it in a browser, but specifically on GitHub anyway, when it sees an MD file, it knows how to format it and present it.
Yeah.
Yeah. Okay, Patrick has a good question here. So this is, maybe I'll get Jesse to take a stab at this one. We're using in our dev team Sourcetree as a client, but we get a lot of changes in traditional design elements like agents, views, and script libraries, where the $assist info field differs between ODP and Git after a sync. These files get listed as unstaged files. How can we avoid this?
That is a good question. I don't have an immediate answer because this does sound vaguely familiar, but the thing is that from recent experience, the $assist info field contains important information, like, because there are other fields that will be kind of like last run, that sort of thing. And so for the fields that do that aren't as important as assist info, like so metadata and things like that, that's where Swiper comes in. If there are other fields that are changing with unnecessary changes, then that would be good to. I mean, Swiper hasn't changed in a while because it hasn't needed to, but that would be a good potential enhancement for Swiper to add other things to remove. So, $assist info itself contains, agent run information. So like that, changes are changes, but there are other things that Swiper will take care of.
Yeah, Swiper was my first thought when I read the question. Okay, next question is, can I download an NSF from GitHub or only DXL? In other words, can I download an NSF in NSF format from GitHub or only DXL? And if only DXL, how do I turn that into an NSF?
For the first question, the answer for that would be if the author put one up there. So, potentially if you are running a project where you run it with source control, and then you tag a new version, you might put up an NSF, like a binary distribution, or a zip containing licensed NSFs and what have you. You might put that up as a attached file on the release. Potentially, you could put an NSF as just in source control directly, like if you make copies of it or something, and put that in Git Lfs. I would recommend not doing that. You can, but I wouldn't recommend it. As far as how you turn DXL, like, so if you do clone a repository that has an ODP, I didn't mention it in my slides, although I probably should have. So in there where you have the team development set up source control for an NSF, Designer also does the reverse, where if you open up the package explorer view, so window view, show view, package explorer, you can right click there and import the project. So an ODP is itself an Eclipse project. So if you import that project into Eclipse, you can then right click that and say create new NSF from this. So that will also have a team development submenu on the right click menu. So it goes both directions there, where you can go start from an NSF and say create new on this project, and you can go from an on this project that you have imported into Eclipse and say create an NSF out of this.
Yep, and David's Notes in 9 video that you referenced in your slides shows exactly how to do that.
So for Domi, for example, we've got a release folder at the top level that has a zip of the NSF, and we keep that up to date as well. So,
cool.
Yeah.
Okay, next question. Can Git be used to manage Domino Vault files?
Probably not, I don't think.
Well,
because,
I think, because I think Domino Vault files are like zips of XML, something like that.
don't think, yeah, I'm not sure if they can be opened from that, but you could still use it for managing the whole version, but you wouldn't be able, it wouldn't show changes on particular forms in a Vault app, for example, or additional JavaScript files that you added into the Vault app.
Yeah, that's something where I think that, you could potentially, because I do believe they are just zips of like XML and related files. And so in theory, you could have some scripts that would handle, unpack a current zip into source control and then a script to repack it into something. So essentially like a much simpler version of the stuff that I've done for NSFODP, where it's taking an existing bundled up one because the format is so much simpler and friendlier. So as far as I know, just by default, it wouldn't be like, I don't know that if there's like a build tool for Vault stuff like that, but I think it wouldn't be that complicated. It's just not there I don't think it's there by default, but I may stand corrected.
Picking up another project, another product rather, VaultMX, which has just had its first HCL release, I believe. VaultMX Iris, your client-side application, can be integrated with source control. That's available out of the box from the Iris IDE. That was there previously with when it was Temenos. So you can integrate a Vault Iris project directly to GitHub. VaultMX Iris, sorry.
Okay, we've just got a few minutes left. One more question. The question is, can you deploy easily to Domino production from GitHub? I'm gonna modify that question just slightly and say, can you automate deployment easily to Domino production from GitHub?
Oh boy, that is non-trivial.
I knew that was gonna be your answer.
So that is an unfinished component of the NSFODP tooling. So that does export, it does compile, and it has deploy. That kind of works. It is a little fiddly, and the thing is from GitHub. So one of the main problems with automating Domino stuff is that you need a Domino or Notes runtime available, and like GitHub doesn't have that. And you need not only the proprietary binaries, but you need a server, you need a user or server ID and names.nsf and a notes INI and all these kind of things that go around it. You potentially could, this is something I want to look into about like how you would work into this, especially if you use remote building with NSFODP. So like essentially maybe kind of, I wouldn't, even though I wrote it. I wouldn't use that to deploy to production. You could. I mean, as far as I know, remote deployment works. But I would say, I don't run your company on that necessarily, at least not yet.
Sounds to me like
if anybody wants to help out on the project, by the way,
yeah,
there are people
I
who
was
have
going to
good
say
options.
Two options, right? There's OpenNTF, but there's also the AHA portal, and I'm, without having looked recently, I'm pretty sure I've upvoted a request to do better GitHub and ODP tooling integration. So there's an opportunity for some improvement there.
If you can get HCL to make the replace design thing that Notes does a callable function that's documented, I would be so grateful to you.
Wonderful. All right. Well, that is all of our questions. Again, a big thank you to Paul and Jesse for your time and putting together this material. I think it was very well received and in good detail. And thanks to everyone for joining in today. Oh, one last question that just jumped up. Automation with Project Keep, perhaps? Question mark. Paul, wink, wink.
And Jesse, wink, wink. Yeah, I think that probably comes back to Jess's API for the design refresh, I think.
Yeah, well, yeah, because essentially all the same problems there remain, because they're, essentially what the NSFODP tooling does is, in remote mode, it uses a quick ad hoc REST API I made. And so like, if Keep did the same thing, it would still need to solve the same problem. As far as I know, the official ways to do replacing design, either in notes or with the server task, are not something, I think they're kind of bespoke in their own cases. And so it would be neat if Keep had that capability, or ideally if it was something that everything could use. And so, in theory, Keep could subsume some of this stuff, but I don't think it on its own would actually add much to solving the problem.
Okay, we'll wrap it up there. One reminder for those of you in the webinar at the moment, Howard has created the registration link and put it into the chat for everybody. So for those of you on the chat or on the webinar, you're able to register now. And the webinars page, opentf.org/webinars, will have that link in it. And this YouTube recording will be uploaded later today. With that, thank you everyone, and enjoy the rest of your day.